Assalamualaikum warahmatullahi wabarakatuh and very good day to my panel. My name is Amir Arrashid bin Abu Bakar and I am student of Mechanical Engineering from College of Engineering at UiTM Shah. So today I will present about my final year project with the title Design of Flexible Storage Bin for Packaging Box for Karakuri Assembly Line. Before we start, I would like to thanks to my supervisor IR Dr. Nur Azilna binti Muhammad Saleh for helping and guide me during this project. This is content that we will go through during the presentation. The content are first introduction, second problem statement, third objective, fourth scope of work, fifth research methodology, and sixth result and conclusion. Begin with introduction. This project was carried out using Karakuri method. Karakuri system use gravity force to move the product from higher position to lower position with its mechanism, such as spring, gear, and roller. Many manufacturing industry are already applied the system in production line because it is the key to low-cost automation that can increase the productivity. Therefore, the Karakuri system will be used to design and simulate in this project. This design project was focused to package the product during assembly line. CATIA software will be used to design the inventory for packaging box and simulate using Blender software. For problem statement during this project, first is how to design the flexible inventory. Second, what material will be used to making the inventory box. Third, determine what mechanism to release the box from inventory. The objective of this project is first to determine the flow of product due to gravity in storage bin. Second, to implement Karakuri Kaizen to the inventory system in order to cut labor costs. Third, sketch and draw a flexible design of mechanism using CATIA software. Scope of work in this project. First, design concept. 3D drawing produced with the CATIA software. Second, CATIA V5 software to design the flexible inventory for packaging box. And third, Blender software. Simulation will be used to show how the mechanism works. For methodology, Six Sigma method will be used to carry out in this project, which are first define, second measure, third analyze, fourth design, and lastly verify. So first method is define. Define is the method of recognizing the project challenge. The major difficulty for this project outcome is determine how to design a flexible inventory for packaging box in terms of its horizontal or vertical position and changing size of the product part to the assembly line. The material will be used must easy to form a shape, low cost, light in weight, and good surface finish with fine color. For material cost, as usual, it must be lower cost to cut the cost budget and the size is depend on the product part to be packed. The design project must be easy to maintain and can be adjustable to achieve the target. Lastly, for the safety, the material must be anti-sketch, high peel, and high strength impact. Second is measure method is the most significant aspect of automation to recognizing each process sequence and its function. Therefore, morphological chart is used to brainstorm the idea to be chosen and create a good product. After morphological chart, three design concepts has been created. First design, the size inventory can be adjusted through bar slot. Second design, the size inside inventory can be adjusted through surface slot. And third design, the size inside inventory can be adjusted through partition. Next, after collect all of data based on the problem, The data was analyzed. From the illustration, first option, the position for arranging box inside inventory is based on product part travel through the assembly line. When the product travel in horizontal, the box will arrange in vertical position inside the inventory box. Otherwise, when the product travel in vertical, the box will arrange in horizontal position inside the inventory box. After design concept has been done, the design will be compared using path chart to fulfill the outcome criteria. The design must be evaluated and design 3 receive the highest from overall score. Therefore, design 3 has been selected as final concept that will be used in this project. Next slide is design. The software used for design the flexible inventory for packaging box is Katia V5 software. The inventory is designed to adjustable in terms of size and position of the box inside the inventory. Therefore, the box can be arranged in vertical or horizontal in position due to the assembly line. After complete the design, the file will be transferred to Blender software to simulate the flow. To verify the dynamic analysis between product release and current quick slide, these formulas are used to investigate the kinematic motion of the box from inventory to assembly line. This calculation used to measure the force to push the box from the inventory, and this calculation used to determine the cycle time box transfer from inventory to assembly line. For the result, after follow Six Sigma method for methodology, the result has been achieved based on 3D design of flexible inventory box, second, pushing force and cycle time, third, cost estimation, and lastly, simulation process. Result for 3D design of flexible inventory for packaging box. The design of inventory for packaging box are flexible where the box inside the inventory can be arranged in vertical and horizontal position. Next, based on dynamic analysis, the force needed to push the box from inventory box 1, which is bottom part, is 0.173 Newton, and inventory box 2 for top part is 0.165 Newton. The product release at T1 is fixed as 2 seconds. Lastly, the cycle time for box transfer to assembly line for inventory box 1 are 2.31 seconds and 2.37 seconds, where for inventory box 2 are 2.25 seconds and 2.32 seconds. After collecting the data, servo X1 from the Arduino component is chosen as the part release mechanism, since the need to force to release the product from inventory part is minimum. For cost estimation, all the material cost has been listed up to calculate the total cost. Mostly the high costs are on machining and acrylic sheet. The last part for result is simulation. The simulation is focused on packaging section at the assembly line. It is to show how the flexible inventory for packaging box operate at the assembly line. The simulation applies the same concept when the position of the product part has been changed in position. The first video is to show how the box arranged inside the inventory change in position. So this is first video. So first, remove the vertical box, and second, remove the bolt and nut. Third, change the partition. Fourth, tighten back the bolt and nut. And lastly, insert back horizontal box. The second video is to simulate the product part travel at the packaging section. So this is second video. This is inventory box 1 and box 2. The product we travel to inventory box 1 and continue to inventory box 2. Lastly, the 3 box will fit in the big box. Lastly, for conclusion, first, the flexible inventory for packaging box was applied at the assembly line successfully. Second, it is designed to store 30 boxes at the same time for inventory box 1 and box 2. And third, the position of the box inside inventory can be chosen in horizontal or vertical position. And lastly, fourth, the dynamic analysis was carried out to determine the cycle time. That's all for my final year project presentation. Here I attach my contact detail for Q&A session. Once again, thank you very much to my supervisor and panel.